NASA's Exoplanet Exploration Program is leading humankind on a voyage of unprecedented scope and ambition, promising insight into two of our most timeless questions: where did we come from? Are we alone? The primary goal of the program is to discover and characterize planetary systems and Earth-like planets around nearby stars. The missions are designed to build on each other's success, each providing an essential step forward toward the goal of discovering habitable planets and evidence of life beyond. The first phase of exploration entails building an understanding of how many and what kinds of planetary systems nature has provided. Much of this work has been done with ground telescopes around the world, pushing the limits of their ability to detect smaller planets through Earth's turbulent atmosphere. The Kepler mission, in the stillness of space, is probing deeper into the galaxy to detect smaller and more Earth-like planets around other stars. Future NASA and international missions, as well as larger and more sensitive ground observatories, will extend this exoplanetary census much farther in the coming years. At the same time, important investigations will tell us about the environments around stars with exoplanets, such as dust and debris in disks, that could make further measurements of the planets more difficult. Ultimately, the goal is to see whether there are exoplanets that show signs of possible life that we know how to interpret. The evidence will be primarily in the form of detailed spectroscopic studies of the atmospheres of extrasolar planets. For a planet to host life, our expectations are that the planet would require liquid water on the surface. We do not assume that the planet would necessarily resemble Earth itself. It would lie in an orbit that is neither too close nor too far from its star, so that liquid water could exist over geological timescales, and its atmosphere would contain the right balance of gases that could support life. Moreover, the atmosphere of the planet would be altered by the presence of life, such that only the existence of living organisms could account for the unusually high levels of gases in its atmosphere. It's not that scientists reject any possibility of other life forms than what we know, but we do not yet know what other life forms could exist or how to look for them. The volume of space that would be explored would be limited to the closest stars. In this context, nearby is understood to be stars that lie within approximately 20 parsecs, 60 light-years, from our Sun. This is roughly the distance we can explore using technologies available in the next decade. The ultimate stakeholder in the adventure of exoplanet exploration is the public who underwrites it. NASA's Exoplanet Exploration Program is especially interested in making materials and information available so that all can appreciate and understand the new scientific discoveries and the challenges ahead, and to engage and inspire students to take interest in technical and scientific matters. Small and medium-class pilot astrophysics missions, as well as astrophysics missions of opportunity, are selected under the Astrophysics Explorers program and are managed by the Astrophysics Division. Explorers are opportunities for focused scientific investigations and fill the scientific gaps between the larger missions. For example, the Nuclear Spectroscopic Telescope Array (NUSTAR) is conducting a census of black holes for the Physics of the Cosmos program and studying the birth of elements for the Cosmic Origins program. In April 2013, the Transiting Exoplanet Survey Satellite (TESS) was selected to move into formulation. TESS will identify terrestrial planets in the habitable zones of nearby stars. The Neutron Star Interior Composition Explorer (NICER) mission of Opportunity was also selected in April 2013. It will be mounted on the space station and measure the variability of cosmic X-ray sources to explore the exotic states of matter within neutron stars and reveal their interior and surface compositions.